Last time we finished equilibrium. Do you have any doubt in it? Tell me if you have any doubt. No doubt. Okay. Today I'm going to start with the next chapter that is known as redox reactions. Can you see my screen? Redox reactions. To understand the redox reaction, first of all, we are discussing about what is oxidation and what is reduction. What is oxidation? What is reduction? To explain this concept of the oxidation reduction, we have number one is the classical concept. According to this classical concept, addition of oxygen or removal of hydrogen, removal of hydrogen, addition of oxygen or removal of hydrogen, right? For example, if I say I'm adding oxygen to magnesium, sodium, right? It is giving N2O, Na2O. This is a oxidation process, right? Or if I say magnesium plus oxygen to give you MgCl2, MgO2, MgO. So this is the addition of oxygen to the magnesium, right? This is a process of reduction, process of oxidation, right? Or you can remove hydrogen from some element like this MgH2 plus oxygen. You can remove here and get a magnesium plus hydrogen oxide. So you have removed the hydrogen from the magnesium hydride. This is called as a oxidation, or it can be reversed also. That is addition of hydrogen or removal of oxygen. That is called as a reduction. For example, if I say sodium plus hydrogen to give you NaH, this is reduction. Or if I have Na2O plus H2 to give you sodium plus water, right? This is also a reduction. Reduction means either addition of hydrogen or removal of oxygen. Either addition of hydrogen or removal of oxygen is called as a reduction. Right? Getting me? Right. This is the classical concept. And now I'm talking about the modern concept. According to modern concept, oxidation is loss of electron is called oxidation. Loss of electron is called oxidation. Suppose I say sodium is losing electron, then we say it's the oxidation. Right? If I have an Mg1 positive, it is now losing one more electron and become 2 positive, it's a loss of electron. It's already 2 negative ion losing one electron only, it's oxidation. Cl negative ion losing one electron becoming neutral. These all different cases of oxidation. Basically, loss of electron is called oxidation. Understood? And gain of electron is called reduction. Gain of electron is called reduction. Chlorine plus electron to become Cl negative. This is the gain of electron, and the gain of electron is called as a reduction. Gain of electron is called as a reduction. O negative plus 1 electron become here O2 negative ion. Okay. Reduction process. See, right? Or if there is a already one negative charge and we are adding one more electron, it become O2 negative ion. By any ways, it is gaining electron. This is called as a reduction process. Understood? Now, another concept I am introducing is oxidation number. In terms of oxidation number, what is oxidation number? Write down. It's a charge that an atom of an element appears to have when present in the combined form. When present in the combined form. When present in the combined form. Suppose I say NaCl, then the chlorine is negative and sodium is positive. Because in its combination, sodium has lost one electron and chlorine has gained one electron. It is Na positive, Cl negative ion. Na positive and Cl negative ion. Na positive and Cl negative ion. This is a charge that the atom or ion are gaining, right? So basically, when I separate them, I'm getting here Na positive and Cl negative ion. So plus 1 is oxidation number of sodium and minus 1 is oxidation number of chlorine. Getting me? So how to determine the oxidation number? There are certain rules. Write down rule number 1. Oxidation number of hydrogen is always taken as plus 1. Oxidation number of hydrogen is always taken as a plus 1, except, except there are some exceptions there. In case of alkali and alkaline earth metal hydrides, alkali and alkaline earth metal hydrides, like NaH, Na positive, NH negative, Na positive, H negative. So the oxidation number of hydrogen is a minus 1 charge here. And alkaline earth metal is group number 2 element, MgH2. it will give you Mg2 positive and 2H negative ion. So hydrogen is acquiring oxidation number is equal to -1. Hydrogen acquires their oxidation number -1. Oxidation number is equal to for +1, right? But in case of alkali metals and alkaline earth metal hydrides, the oxidation number is equal to -1. Oxidation number of oxygen is generally -2. It is generally -2. Except, except in case of the elemental form like O2 that is taken as a 0, number one exception. Number two, in case of the peroxides. Peroxides are those in which we have O single bond O. Here the oxidation number is equal to -1. You can see I'm putting here X and X. I can say 2X. Hydrogen is +1 by the rule number 1. 1 plus 1 is equal to 2 or X is equal to -1. That's why I'm putting here -1. Third exception case. In case of superoxides. +1, 2X, -1. So X is equal to -1 by 2. Generally, it is taken as a -2, but the exception that I had told you, that is in case of the peroxide, it is -1. In case of superoxide, it is equal to -half. Am I clear? Now, next case. Oxidation number of a substance in the elemental state is taken as 0. Suppose I say hydrogen exists as H2, then it is 0. Cl2 0. O2 0. Iron, sodium, magnesium, all these are in the state of 0 here. All these in the state of 0. Am I clear? Right. Now, oxidation number of any ion is equal to its charge. If I say sulfide ion, then oxidation is equal to -1. Cl is equal to -1. Sodium positive is equal to +1. Whatever the charge is there on the ion, it is taken as that charge. Am I clear? Aluminum ion +3. Whatever the charge is there on any ion, that is its oxidation number. That is its oxidation number. Clear? Now, let us calculate the oxidation number of the halogens. This fluorine always gain 1 electron, so its oxidation number is equal to -1. Chlorine that can have -1, +1, +3, +5, +7, depending upon the compound. Suppose I say HCl. So hydrogen is +1, so chlorine is -1. Hydrogen is plus 1, chlorine is minus 1. In case of Cl2O, it is a 2x minus 2 is equal to 0, 2x is equal to 2, or x is equal to plus 1. You can see here, in this case, it is coming out to be is equal to plus 1. Getting me? Right. Then we have Cl2O3. 2x minus 2 into 3 is equal to 0. 2x minus 6 is equal to 0. 2x is equal to plus 6. X is equal to plus 3. In this compound, it is coming out to be plus 3. Note it down. Calculate for I2O5, I2O7. Can you calculate for iodine? No. We are putting a 2x. Oxygen is a minus 2 charge into 7 is equal to 0, or 2x is equal to 14, or x is equal to plus 7. Getting me? Okay. Now you calculate oxidation number of manganese in this compound. It is a alkali metal, means group number 1 element. When I say group number 1 element, it is now 2x plus, no, alkali metal is plus 1. So it is 1 plus 1, 2. For the manganese, I am taking x. Chlorine is minus 2 into 7 is equal to 0, or x is equal to plus 6. Getting me? You got it how I calculated it? Now, K2Cr2O7. Can you calculate for the chromium here? One plus one for potassium is 2. It is 2x here. Minus 2 into 7. So 2x minus 14 is equal to 0. 2x is equal to minus 12 is equal to 0. 2x is equal to 12, or x is equal to plus 6. Alkali metal is plus 1. All the alkali metal, lithium, sodium, potassium, rubidium, they can lose only one electron. Now, NO3 negative. We have to calculate for the nitrogen here. For the nitrogen, I am choosing here X. Oxygen minus 2 into 3 is equal to overall charge minus 1. So X minus 6 is equal to minus 1. So X is equal to plus 5. Got it? ClO4 negative. Calculate for chlorine. X minus 2 into 4 is equal to minus 1. X minus 8 is equal to minus 1. So X is equal to plus 7. You got it now? Okay. Okay, now calculate for MnO4 negative ion. Calculate for manganese. Yeah. See, minus 2 into 4 is equal to, you're missing this charge, minus 1. Okay. Calculate for phosphorus here, Na3PO4. For sodium, you have taken 1 plus 1 plus 1, 3. Sodium is alkali metal. Phosphorus X. Oxygen is minus 2 into 4. So 3 plus X minus 8 is equal to 0. Or X is equal to now plus 5. Got it? Now, if I say I have this zinc plus HCl, it will form ZnCl2 plus hydrogen gas. Right? Oxidation of zinc is 0 here. And here it is a plus 2. Got it? Because chlorine is minus 1 here. Hydrogen plus 1, chlorine minus 1, it is 0 here. You got it how I calculate the oxidation number? From 0 to plus 2, there's an increase in oxidation number. It means zinc has lost electron. So what is loss of electron? Can you tell me? It is a oxidation, right? It means zinc is undergoing oxidation. Chlorine here is a -1 hydrogen here is a +1 to 0. It means the H positive gain one electron becoming H atom. Got it? Gain of electron is called reduction. It means hydrogen has undergone reduction. Am I clear? It means we can say zinc is undergoing oxidation and hydrogen is undergoing reduction. It is forming H2 gas, right? If we add the two equations, what we have had, this is 2H positive ion to give H2 plus Zn2 positive. Got it? So zinc is undergoing oxidation. It is losing all electron because of the H positive ion. So this is a reducing agent, which is an oxidizing agent, sorry. In the presence of the H positive ion, zinc is losing electron. Otherwise, it would not have lost. It is a oxidizing agent. And the electron lost by the zinc are gained by the hydrogen. It means this zinc is the reducing agent. Reduction takes place only when electrons are available. H positive will gain electron only when zinc will lose electron. It means zinc is the reducing agent and the H positive ion is oxidizing agent. It means I can say reducing agent is the one which lose electron. Or I can say whose oxidation number increases 0 to plus 2. You can see oxidation number increases. That is the reducing agent. Understood? And oxidizing agent is the one which gains electrons. Whose oxidation number decreases. You can see 0 plus 1 to plus 1 here, 0 here. Whose oxidation number decreases. Understood? So reducing agent is also called as reductant, which gives electrons whose oxidation number increases, right? and oxidizing agent is the reverse of it. It is also called as an oxidant, which gains electrons, whose oxidation number decreases, whose oxidation number decreases is the oxidizing agent. Understood? Next point. Now, zinc plus copper sulfate to give zinc sulfate plus copper. Here I have reaction. In this reaction, oxidation number of zinc is 0 because it's an elemental state. Copper is plus 2, zinc is plus 2, copper is 0 here. Okay. So you can see that zinc has lost electron. It is undergoing oxidation. And the copper ions are gaining electron. It is undergoing reduction. Since zinc is undergoing oxidation, it is giving electrons. So I can say this is a reducing agent which is giving electron. And copper ions are gaining electron and becoming copper. This is an oxidizing agent. Sulfate ions here are spectator ions. Sulfate ions are here spectator ions. They are not involved in any oxidation or reduction. They are not involved in any oxidation or reduction. Right? Electron cancelled here. I am writing in the net equation copper 2 positive to give copper plus zinc 2 positive. Where the oxidation is going on, loss of electron, this is called as a oxidation half reaction. And copper is undergoing reduction, so we call it as a reduction half reaction. And the net equation is, it is called as a redox reaction. Understood? Now, in this process, we can see the electron lost by the zinc is gained by the electron. And during this process, the electrons are traveling, electrons are flowing. What do you call the flow of charge? Or flow of electron? What do you call it? Yes. It means in this chemical reaction, electricity is generated, and that device which converts the chemical energy into electrical energy is called as a electrochemical cell. The cell which converts chemical energy into electrical energy is called as a electrochemical cell. Understood? So let us see this reaction now. Here we have copper sulfate solution, that is blue color solution. And inside it we are dipping zinc. There are some observations. Number one, zinc is eaten away. Zinc is eaten away. Eaten away means it is getting dissolved like this. And second, the blue color fades away. And the copper metal deposit on zinc rod. These are our observations. Understood? Now let us see why, how it is happening. To explain this, it is the electrochemical theory that zinc that is solid is undergoing oxidation. It is losing electrons. And the copper ions are gaining electron to become copper. Electron cancelled. Now zinc plus copper ions to give copper plus zinc ions. Right? Electron lost by the zinc are gained by the copper ions. Understood? Noted down? Now, it means current is generated. But if you pass here two wires and connect it with any device which works upon the current, let it be bulb, will it glow or not? Will it glow or not? It will not glow actually. Practically, it is found that there it is not glowing. Even though we have proved that current is generated, right? But the problem here is number one, circuit is incomplete. You can see circuit is not complete. And number two, between the two ends of the wire, there is a there is no any potential difference. No potential difference. Number one, circuit incomplete. Circuit is incomplete. Number one, and number two, potential difference is not there. Due to these two reasons, due to these two reasons, we can say the current will not flow. It means our theory is correct, but some practical problem is here. Let us make it correct now. What we do is we take two beakers. In one beaker we have zinc sulfate, and here I have zinc rod. Here we have copper sulfate, and here we have copper rod. Connect it with voltmeter, right? When the zinc is in zinc, or copper in zinc, copper in copper, nothing will happen. But when we connected here with the copper, our observations are there. Number one, zinc rod is eaten away. Number two, copper rod, copper, metal deposit on copper. It means here the copper is getting deposited, right? Third reading, voltmeter show deflection towards zinc. This voltmeter show deflection towards zinc. And number four, cell stops working after some time. Means the reading that is deflection the voltmeter that stops. Cell stops working after some time. Blue color fades away. Blue color of copper sulfate fades. These are observations there. Understood? Now again, we come to the reason why it is happening. And what is happening is zinc is losing electron, and it is coming out zinc ions which comes in the solution. It means zinc is undergoing oxidation. The electrons that it has lost is going through the wire in this direction. The copper become negative, and from here the copper ions are attracted towards it, gain electron. The copper ion gain electron and become copper. So zinc eaten away and copper deposited. These 2 points are clear now. Okay. And the voltmeter show deflection because electrons are flowing from the zinc to the copper, and in convention this is known as the electronic current. Zinc to copper is called as an electronic current. And copper to zinc is conventional current. Understood? And the blue color is fading because the copper ions are getting deposited here. Blue color are fading because copper ions are getting deposited here. As long as the copper ions will remain in the solution will be colored. Now, cell stops working after some time. The reason is when we started the process, before we started the process, here the zinc ion and the sulfate ions were equal in number, means 1:1 ratio. But with the passage of time, zinc ion number become more than the sulfate ion. Become more than the sulfate ion. As it comes here, what will happen? There will be zinc ion will be extra over here, and the solution will become positively charged. This positive charge will not allow the electron to go away because electrons are negatively charged. And now here we have a copper ions and the sulfate ions. Ratio is 1:1. But now here copper ions are less than the sulfate ions because they have got deposited over there. When they got deposited over there, it becomes negatively charged. When they become negatively charged, the electron coming toward this side will be repelled. Electron coming from this side will be repelled. So electron coming from the zinc or electron coming from towards the copper, the electron flow will stop, and that is why cell will stop working after some time. Right? Our chemical is not finished. Our chemical is not finished. Understood? And to overcome the problem, we have now a salt bridge. To overcome the problem, we have here the salt bridge. Salt bridge is a U-shaped tube with a cotton plug here, and inside it we have agar-agar gel. Inside it we have agar-agar gel, and we have potassium chloride or potassium nitrate or ammonium nitrate. Any one of the three is filled inside it. And now it is fit with the fit with the main cell. Note down this and we'll go ahead. What is salt bridge? Salt bridge is a U-shaped tube filled with agar-agar gel and these. Note it down. Now what you do is, I'm coming back here and I'm placing here the zinc, this salt bridge. You can see red color salt bridge here. Understood? Now, what will happen? These zinc ions will be attracted towards it because here we have potassium chloride inside. See, here we have potassium chloride. The potassium ion will, chloride ion will attract the zinc ions. And here extra sulfate ions will be attracted by the potassium ion. These two half cells will become neutral and cell will now keep on working. Understood? Yeah. Now, next is, in case we have made a zinc and copper cell, zinc is undergoing oxidation and copper is undergoing reduction. Why not reverse? Do you have any idea? Yeah, can you tell me why zinc has undergone oxidation? Why not copper? My question, why not reverse? Why does not circle that copper to lose electron and zinc will gain electron? Okay, what we do is we have another example here. Suppose we make a cell here of the copper and zinc, copper and silver. We find that if we make this cell here, this will undergo reduction and this will undergo oxidation. It means copper can lose electron or gain electron both ways. It can undergo reduction, it can undergo oxidation. Depending upon with which element it is interacting. With which element it is interacting. If it is interacting the zinc, it is undergoing reduction. If it is interacting with the silver, it is undergoing oxidation. It means there is something known as the power to lose or gain electron. Power to lose or gain electron, right? We call this as a electrode potential. We call this as the electrode potential. What is electrode potential? Write down tendency of an element to lose or gain electrons. Tendency to lose or gain electrons is called as a electrode potential. This is of two types. One is called as an oxidation potential, other is called as a reduction potential. What is oxidation potential? Oxidation potential is tendency of an element to lose electrons. Tendency of an element to lose electrons is called oxidation potential. Is called oxidation potential. It is metal to lose n number of electrons. This tendency to lose electrons is called as an oxidation potential. We represent it like this: E m to mn positive slash in between. It is a x voltage. It can lose electrons. Tendency of an element to lose electron is called oxidation potential. And reduction potential is tendency of an element to gain electron. Reduction potential means tendency of an element to gain electrons. It means metal ion to gain electron become metal here, or I can say E naught Mn positive M as something Y volt. Understood? It means, understand here, the element that has a high reduction potential will undergo reduction, and the element that has a lower reduction potential will undergo oxidation. If I say I am having a zinc and copper cell, and zinc is undergoing oxidation and copper is undergoing reduction, that simply means that the zinc slash zinc 2 positive, it's the oxidation potential, right? Zinc is losing electron, is more than the oxidation potential of the copper. Or we can say E naught. Copper ion to copper reduction potential of the copper is more than that of the zinc. Understood? Bilal, just give me a second, please. Yes, Bilal, I'm back. Can you hear me? It means we can say either zinc has a higher oxidation potential, then only zinc is undergoing oxidation, or copper has a higher reduction potential as compared to zinc. That is why zinc is undergoing oxidation, right? Okay. So every element has certain reduction potential value. That is given in the table. We call it the electrochemical series. Do you have book and you can see the electrochemical series? Bilal, do you have do you have book in which electrochemical series is given? Okay. Right now you don't have, or you have, but you have, but right now you don't have. Huh? Okay. Okay. In that series, some values are given. Uh, then from that we can calculate the E naught cell. Means that the cell potential in the potential in the voltmeter, what reading will come. That is equal to the substance which undergo reduction minus substance undergoing oxidation. Right. Suppose I say zinc reduction potential is minus 0.76 volt. This value will be given to you. And reduction potential of the copper is positive 0.34 volt. This value will be given to you. Put here zinc reduction potential, copper minus zinc. Put here the value 0.34 minus 0.76 volt, 1.10 volt. That is how we find out the cell potential value. Got it? Okay, now we come to the next topic. We call it is a balancing of chemical equations. Balancing of chemical equations. This chemical equation is between the two. One is known as a oxidation number method. and other the half an electron, and other the ion electron method. Two methods are there. Oxidation number method and ion electron method. Bill, just give me a minute, please. Yes, Bill, can you hear me? Okay. Here I had this equation. Potassium dichromate. Dichromate ion we have iron ions to give chromium ions and Fe3 positive ions. This is the equation that you have to balance it in the acidic medium. In the acidic medium, right? First of all, I'm discussing about oxidation number method. Oxidation number method. In this method, step number one is write oxidation number of each element at its top. At its top. We have a dichromate ion, iron ions. Now you know how to write the oxidation number, right? Just a second. Yes. Oxidation number plus 6, plus 2, plus 3, plus 3, right? Oxidation number of each element at its top, right? Second step is determine. You got it? How we had done this, Bilal? Okay. Determine increase and decrease in oxidation number. Increase and decrease in oxidation number. Here we have a Cr2O72 negative, plus 6, it is a plus 2, plus 3, plus 3. For chromium, oxidation number decreases by how much? 6 to 3, it is 3. Multiply by 2 is equal to 6 per atom. And iron, plus 2 to plus 3, oxidation number increases by 1. You got it now? Plus 2 to plus 3 increase by 1. And here plus 6 to plus 3, 3. For the 2 atom it will be 6. Then you make cross multiplication. Cross multiplication means for the 1 here and 6 here, you multiply 1 with the iron and 6 with the chromium, dichromatine, in the next step. So what I'm doing here is the next step, Cr2O72 negative ion plus Fe2 positive ion to give ferric ion and dichromatine, chromium 3 positive ion. Just multiply on the reactant side only. Just multiply on the reactant side only. Six here and a one here. Opposite we have to do. Now you balance all other atom except hydrogen and chlorine, hydrogen and oxygen. So you can now balance like this: 6Fe3 positive ion and chromium 3 positive ion. Iron are balanced and chromium also you multiply here with the 2. And after this, what you have to do is, it is taking place in the acidic medium. For the acidic medium, there is a particular method that I'm going to tell you how to balance the high oxygen here. There are 7 oxygen here. You add a 7 water molecule on the opposite side. By this way, you will be balancing the oxygen. And now, for 14 hydrogen this side, you multiply. You add here H positive ion this side. Understood? Any doubt till now? Now you can see the 2 chromium both the side, 6 iron both the side, 7 water oxygen both the side, 14 H positive on both the side. This is a balanced equation. Note it down each and every step. Any doubt in it? No. Next. The same equation can be done by the another method. We call it's a ion electron method. We call this is a ion electron method. Ion electron method. First step, oxidation number +6, +2, +3, +3. Is that clear? Bilal, are you getting me? How to find the oxidation number? Okay. Then what you have to do is, next step is determine oxidation and reduction. Determine oxidation and reduction. Cr2O72 negative ion +6 to +3. +2 to +3. It means this is undergoing reduction and Rn is undergoing oxidation. Increase in oxidation number is called oxidation and decrease in oxidation number is called reduction. Now you separate the two, that is a reduction half reaction and oxidation half reaction. Reduction half reaction is dichromate ion to give chromium ions, and oxidation half reaction is iron ion to Fe3 plus ion. Understood? Now you balance them separately. First of all, I'm taking the reduction half reaction, that is a Cr2O72 negative ion to give Cr3 positive ion. It is a +6 to +3. Decrease by 3 means 6. We have to add 6 electrons on the reactant side. Now you balance all other atoms except hydrogen and oxygen. Now you add water so that we can balance the oxygen. And now you balance the hydrogen by adding H positive ions. That is equal to the deficiency only. Note it down, please. Bilal, I'm sorry, just give me a minute, please. There's some emergency. Just give me a minute. Yes, Bilal. Is any doubt till now? Understood? Or should I explain again? Okay, I'm coming to the oxidation part, second part of it. Second part is here the iron is undergoing oxidation here, right? So second part I'll come now. That is the oxidation half reaction. Now loss of right? This is already balanced. This is second equation now. Just why add one electron and your charge is balanced. All other atoms are balanced. This is second. This is the first equation. That is the reduction half reaction, and this is the second equation. That is the oxidation half reaction. Now you add equation number 1 and 2. That is the oxidation half reaction in dichromatin. Right? It's a oxidation half reaction. And it's a reduction half reaction. Right? Now you have to add the two equations algebraically. Since electrons 6 are here, it is a 1 only. So multiply the whole equation with the 6 and then multiply. Dichromatin 6 Fe2 positive ion to give 6 ferric ions, electron cancelled, plus 14 H positive on this side, 2 chromium ion plus 7 water molecule. Understood? Now you can see everything is balanced in last equation. 2 chromium both the side, 6 iron both the side, 14 H both the side, 7 oxygen both the side. This is a balanced chemical equation. Yes or no? Now I am giving example in the basic medium. Now till now I had discussed example of the acidic medium. Now I am giving example of basic medium. PrO3 negative ion plus 7 minus 1 plus 4. Doing by the oxidation number method first. Two method that I told you, ion electron method and oxidation number method. First step is the equation that you are given, write oxidation number of every element at its top. Second step, determine increase or decrease in oxidation number. Determine increase or decrease in oxidation number. First you write the same equation plus 7, minus 1, plus 4, plus 5. Here the oxidation number decreases by 3. And here the oxidation number increases by 6. Can I see? Minus 5 to plus, minus 1 to plus 5. Note down. This much note down, then I will go ahead with it. Now, cross multiplication. I should multiply 6 with this and 3 with this. In place of it, I will to go for 2 and 1, simplest ratio. Cross multiplication. Just cross multiplication, 6 and 3, 6 here, 3 here. Understood? Okay. Now you balance all other atom except bromine and except oxygen and hydrogen. 2 manganese here. So multiply 2 here. So that I can have both the side 2 manganese. Understood? Now in the basic medium, I've told you the basic medium, count the total number of the negative charge here. It is a 2 negative and 1 negative, 3 negative. Here I have only 1 negative. It means I had deficiency of 2 negative this side. To balance it, add 2 OH negative ion this side. two OH negative ion this side. So negative charge is balanced now. Then next what? Next is here hydrogen. Two hydrogen here. Here I don't have any hydrogen. Just add one water molecule. Hydrogens are balanced. Check. Two manganese both the side. Eight oxygen both the side. 8 oxygen. 8 plus 1, 9 oxygen. 4 plus 3 plus 2, 9. Hydrogen 2. This is a balanced equation. Check if you can do. Understood? Till now, any doubt? Should I go next? Okay. Now the basic medium again, but now by the ion electron method. Ion electron method. First step, writing the oxidation number. Next step, determine the oxidation and reduction. You can see decrease in oxidation number is reduction here, and this is the oxidation here. Now third step, separate the oxidation and reduction half reaction. Separate oxidation half reaction and reduction half reaction. Separate oxidation half reaction and reduction half reaction. First of all, I'm getting here the oxidation half reaction. Oxidation half reaction is I negative to give I2, and reduction half reaction is MnO4 negative ion to MnO2. Now balance these two equations separately. Let us balance the oxidation half reaction. I negative to I2. Just adding 2 electrons this side will balance it. Done. Now we talk about the reduction half reaction, second part. In the reduction, we have MnO4 negative ion to MnO2. See, MnO4 negative ion to give MnO2. So now let us balance it. It is a +7 here and a +4 here. It means I can add 3 electrons this side to balance the charges. Now you have negative charge, have 1 and 3, total 4 negative this side. Here I don't have any. For that, what you can do, 4OH negative ion. 4OH negative ion. Now what you have to do is, here we have hydrogen 4, here I don't have any. If I just add 2 water molecule, hydrogen will be balanced. 4 hydrogen both the side. Manganese both the side. 4 oxygen. Everything is balanced. Equation number 2. Understood? Note it down. Now add the two equations here. Oxidation half reaction is I negative to give I2. This is the first equation. Reduction half reaction we have got MnO4 negative ion, 2 water, 3 electron, MnO2 and 4 OH negative ion. Add them algebraically, multiply here the 3 and multiply here the 2, then electrons are cancelled. 6I negative plus 2 MnO4 negative ion, 3I2 MnO2 plus 8 OH ions. Check. Everything is balanced or not? 6I negative, 6I. 2 manganese, 2 manganese. 4 hydrogen. No, here we have 4. 8 hydrogen, 8 hydrogen. 8 oxygen, 8 plus 8 plus 8, 16. 4 plus 4, 8 plus 4, 12. 12. Everything is balanced. This is a balanced chemical equation. Understood? Understood? Each and everything? Right, perfect. Now, this is the content of this chapter. It is number one, we had done the balancing, oxidation and reduction. Then we have done determination of the oxidation number. Determination of the oxidation number. Then we have done what more? Then electrode potential, electrochemical cell, then balancing by two methods. Which are those two methods? Oxidation number method and ion electron method. Okay. Now, read on one question here. Sulfur dioxide is an oxidizing agent and reducing agent. Why? Both. It is both. Understood? Can you tell me why so? Calculate oxidation of sulfur here. Can you calculate oxidation of sulfur here? Bilal, it is coming out to be equal to 4? Yes or no? And sulfur, if we see the atomic number of sulfur, it is equal to the 16. And if you write electronic configuration, it is a 3s2 and 3p4. It means maximum it can lose plus 6 electron. And it can also gain 2 electron to get the complete octet. It means it can have minimum of oxidation number -2 and maximum plus 6. And here we have a plus 4. It means it can lose electron to get plus 6 or it can gain 2 electron to get -2. Okay. It means it's very clear that it can lose electron and that is why it will act like a reducing agent. It can gain electron and so it will act like an oxidizing agent. Right. Okay. Now if we talk about nitric acid, HNO3, calculate the oxidation number of the nitrogen here. Yeah. What is oxidation number nitrogen? I'm asking you. 1 for the hydrogen, X oxygen is -2 into 3 is equal to 0. So 1 minus 1 plus X minus 6 is equal to 0 or X is equal to plus 5. And you can see the nitrogen atomic number is equal to 5 is equal to 7. Electronic configuration is 1s2, 2s2, and 2p3. Maximum it can lose is +6, +5. Minimum it can be -3. It is already +5 here. It means it cannot further lose electron. It cannot act like a reducing agent, but it can gain electron to become -3. It can act as an oxidizing agent. Am I clear? Let me know if you find any difficulty. No. Right. I'm stopping sharing for some time. Okay, yeah. Till now, any doubt? Ask me. No doubt. Okay, right. So that was all in this chapter. We have finished it today. You'll be getting one assignment after the class. Do it. We can do it next time. Right? Okay. That's all for now. We are ending the session now. Still, if you have any doubt, you can ask me. No. All right. Okay. Then I'm ending the session now. Goodbye for now. See you next week.